So as we discussed at the end of the last video, and you saw in section R.4, expressions A plus B and A minus B are called conjugates. Conjugates just means that those signs inside there, one is positive and one is negative. So expressions A plus BI and A minus BI are also called conjugates, specifically complex conjugates. Now, anytime you take a complex number multiplied by its conjugate, you're going to get a number where the imaginary terms fall out. Here's a couple of examples. If you have the number 3 plus 7i, its conjugate is 3 minus 7i, and if you would FOIL those out, first times first would be, I'll write it up here, I'll write it right here, 9. Outer times outer, the 3 times the negative 7i would be negative 63i. Inner times inner is positive 63i. And last times last is minus 49i squared. So the beauty of multiplying a complex number times its conjugate is these I parts fall out, leaving us with 9 plus 49, 58. You can see the other example there. Now, this is the idea we have to use to divide. Our fourth operation is going to be to divide complex numbers, such as, look at number 82. 10 minus 3i over 11 plus 4i. In that case, what we have to do is, to get this divided, we have to multiply the numerator and the denominator by the denominator's complex conjugate. That is what is going to work for us. That's really the only legal algebra thing we can do. Taking this problem, we're going to multiply by a form of 1. We're going to do the same thing to the top as we do on the bottom. And that form of 1 we're going to use is it's going to be the denominator's conjugate. So the denominator is 11 plus 4i. Its conjugate is 11 minus 4i. So we're going to multiply both the numerator and the denominator by the denominator's conjugate. That is how we're going to divide complex numbers. So now when we go to do that, we've got a lot of multiplying we need to do. We need to FOIL out the numerators as well as FOIL out the denominator. So when we FOIL out the numerator, first times first is 110. Outer times outer is negative 40i. Inner times inner is negative 33i. And last times last is plus the positive 12i squared. If we go ahead to simplify the numerator, this I squared, recall, is negative 1. And so we have 110 minus 12. 110 minus 12 is going to give us 98. Negative 40i combined with a negative 33i gives us a negative 73i. That is the numerator simplified. We must also multiply out the denominator. So first times first, 11 times 11 is 121. Outer times outer is negative 44i. Inner times inner is positive 44i. And last times last is negative 16i squared. Now notice what happens. The negative 44i and the positive 44i fall out. And so we are left with 121. And then the negative 16 times the I squared, which is negative 1, is going to be positive 16. And so our answer, well, not quite yet, is 98 minus 73I all over 137. Now, this isn't quite written in the form A plus BI. To get that in the form A plus BI, we're going to split the fraction. Our final answer is going to be 98 over 137, that real part, minus 73 over 137I. Now our answer is in the form A plus BI. On number 84, we're first of all going to write this problem as, this is this quantity to the negative first. So I'm going to get rid of this negative 1 exponent by writing this as 1 over quantity 4 minus square root of 3I. Now it's to the positive first. So essentially our problem is the same thing as 1 over 4 minus square root of 3I. Now we're ready to divide. And once again, to divide, we're going to multiply by a form of 1. And the form of 1 that we're going to use is going to be the denominator's conjugate. 4 minus 3, the square root of 3i's conjugate is 4 plus the square root of 3 times I in the numerator and in the denominator. Now let's multiply. 1 times 4 plus square root of 3I is just 4 plus square root of 3I. In the denominator, we're going to need to FOIL out. First times first is 16. Outer times outer is going to be a positive 4 square root of 3I. Inner times inner is going to be a negative 4 square root of 3I. And last times last, this negative times this positive is going to be a negative. Square root of 3 times square root of 3 is just 3. And then the I times the I is I squared. So in the numerator, we have 4 plus square root of 3I. And in the denominator, a lot of things simplify. 4 square root of 3I minus 4 square root of 3I falls out, leaving us with 16. And what's going to be plus 3? 16 plus 3 is 19. So our final answer in the form A plus BI is 4/19 plus square root of 3 over 19I. The last thing in this section is to fill out the blanks for the concept connections. The imaginary number I is defined so that I is equal to the square root of -1 and I squared is equal to -1. For a positive real number b, the value square root of -b is the same thing as I times the square root of b. And sometimes that square root of b will simplify. Remember we had square root of -9. Well, that rule says that that's going to be I times the square root of 9. So I times 3. Looks a little prettier to write that as 3I. Remember that example? On number 3, given a complex number, A plus BI, the value of A is called the blank part, and the value of B is called the blank part. In the complex number A plus BI, A is called the real part, and the B is called the imaginary part. Given a complex number A plus BI, the expression A minus BI is called the complex. We just used this to divide. It's called the complex conjugate. We're finished with 1.3. Time to do 1.3 homework.